So here we've got a trig equation to solve, and when you look at it, there's quite a lot to it here. I'm not going to look at the actual domain for x values for now, because that will only happen when I do my inverse sine or inverse cos in the last few steps. So we've got a choice to make. Here's sine x, here's cos x. I don't think I can build these up into sine 2x or cos 2x. I think it's much easier to split these up into sine x's and cos x's. Now this is straightforward because there's only one possible formula. You've got to make a decision for this one. So automatically you should have cos 2x is cos squared minus sine squared, or 1 minus 2 sine squared x, or 2 cos squared x minus 1. Yeah? So you got one of three to choose from. Now they all three should work out quite nicely, but what I like to do is I like to see this side as a 1 here. So if I had a plus 1 on this side, it would cancel out with the plus 1 on that side. It just might make things a little bit simpler to factorise possibly in the end, because it's an equation, so you think about factorising. So how do I get a plus 1 here? Well, it's a negative here, isn't it? So I need a negative, and then I need a negative 1 in here. And so this is how I'm kind of building up my thought processes onto how to speed this question up a bit. Because the sine 2x is 2 sine x cos x, that's not a problem. So now I think your choice is made for you, because the negative cos 2x, yeah, this is now definitely, isn't it, 2 cos squared x minus 1, because the minus will make it a plus. So this has simplified things considerably, and we'll see if it gets us anywhere. Minus 2 cos squared x. Okay, that'll be positive 1, but that'll cancel out with the 1 here. I'm going to bring these terms over as well. Yeah, now it looks quite complicated, but it's not really. You can actually do something you did in grade 9. You're going to factorise in pairs. You can do pairwise factorisation. So I'm going to pair these two up here. I'm going to pair these two up here. Now when I see this term and this term, sine x is a common factor. So I'm going to take sine x out as a common factor for the first and the third term. So when I take out the sine x, I've got 2 cos x left here, minus 1. And then for this one and this one, I'm going to take out, well, cos x is common. Cos x is common, isn't it? But I'm going to take out a negative cos x, and you'll see why now. So that will leave me 2 cos x minus 1 equals 0. So the key thing is knowing that you're going to be factorising at some stage, choosing a nice cos 2x identity for here. And now you can see where we're going with this. Sine x minus cos x factored with 2 cos x minus 1. My writing's getting a bit worse, but that's okay. Equals 0. Okay, so we've got to solve sine x minus cos x equals 0. Yeah, or 2 cos x minus 1 equals 0. This is going to collapse into tan x function, yeah? So you're going to divide all terms by cos x, and you'll get this, that tan x equals 1 to solve. And over here you're going to get cos x equals a half to solve. Okay, so all the work's done now. But still, you've got a little bit of work to get the final answers, because we're looking from negative pi to pi for the solution. So just to help visualize things, I'm going to have a cast diagram here. Yeah, and so the cosine is positive. So cosines are positive in this quadrant here and this quadrant here. And arc cos of a half, that should be instantaneous for you guys. That's 60 degrees or pi over 3. So there's a pi over 3 here, but it also exists down here. So we've got x equals pi over 3, and that's a positive and a negative. Yeah. And over here, again I'll draw a cast diagram. C-A-S-T. Tan of the angle is positive, so tans are positive in here and here, and arctan of 1 is 45 degrees is pi over 4. So you've got a pi over 4 here, and you've got a pi over 4 here, but you've got to consider the domain for x. So x measured down the positive sense is pi over 4, and x measured round in the opposite direction is going to be negative 3 pi over 4. Okay.